Hi, welcome to the presentation on differential equations. We know what is an equation is, and we are all familiar with the way of finding the solutions of the quadratic equation, cubic equations, and biquadratic equations. These differential equations are different from those equations by having the solutions as functions. You know, if we consider a quadratic equation, the solution is a real number. For these differential equations, the solution is a real valued function. Now, what it is, what is a differential equation? Differential equations basically contains dependent variable, dependent variable plus independent variable. We know the dependent variable in a function y is equal to f of x is y, independent variable is x, and differential coefficient of dependent variable with respect to independent variable, that is dy over dx. That is a differential equation. Let me write some examples of the differential equations, like 3y negative 8x times dy over dx plus x is equal to 0. I'm first, I'm writing the examples of the differential equations. So in this first differential equation, we have dependent variable, that is a y, and independent variable x, and differential coefficient of dependent variable with respect to dependent variable. This is dy over dx. Let me write one more. It's d square y over dx square plus dy over dx whole power 5 is equal to 0, and 1 plus dy over dx power 2 whole power 3 over 2 is equal to d square y over dx square. And one more, x dou u over dou x negative y dou u over dou y is equal to e power of x fifth dou square u over dou x square plus dou square u over 2y square plus something y is equal to something cosine of x, like that. By seeing these differential equations, we can recognize one thing. A differential equation can have the highest order derivative, like d square over dx square, d cube y over dx cube, like that. And the power of dy over dx, it can be 1, it can be 2, 3, 5, like that. In this first example, we can see first order derivative. In the second example, we can see second order derivative, and the power of dy over dx is 5. And in the third differential equation, the highest order is 2, means uh, the function y is equal to f of x is differentiated 2 times here. And in the equation 4 and 5, we can see the partial derivatives. We are all familiar with finding dou u over dou x, dou u over dou y. And if you don't know, that's not a problem, because in this presentation, in the future presentation, I will not consider the problems involved in partial derivatives. So by seeing these differential equations, we can observe the order and the power of dy over dx or d square over dx square. So with this observation, we can define very two important terms with respect to differential equations. They are order and degree. That is order and degree. This order is nothing but the highest order derivative. Highest order derivative which is involved in a differential equation. This is very easy to recognize. In the first differential equation, the highest order is 1, which means we can see a function y is equal to f(x) is differentiated one time. In the second equation, the order is 2. I will write here order is 2. Here order is 1. And let me come to the yeah, let us consider this third example. Here in this, the order is 2. Here in the fourth equation, the order is 1. Here in the fifth, it is order is 2. Now it is a time to talk about degree. What it is? Please be attentive while telling the degree of a differential equation. This gives the highest order derivative positive power. The positive, this is very important term, positive integral power of highest order derivative. Highest order derivative determines the degree of the differential equation. Here in the first example, the degree is 1. It is because the highest order derivative is dy by dx, its power is 1. Let me change the color so you can easily understand. And in the second equation, the uh, highest order derivative is 2 and its power is 1. So for this, degree is 1. Now come to the differential equation 3. Here we can see a rational number. If we have rational number, we should make it as some integer, positive integer. What I mean is, a differential equation should have the power of dy by dx or d square by dx square like 1, 2, 3, and we should not have 3 over 2. So what we can do here is to find the order. To find the degree, what I will do is I will square this equation 3 on both the sides, so that we can get rid of this radical, that is square root of 1 plus dy over dx square power 3. So I got 1 plus dy over dx whole power 2 whole power 3, that's equal to d square y over dx square. Now the order is 2 and the degree is 2. it is this problem, we can say most of the students will say the degree as one by just looking at this, but please see this rational number we should not have. So I am squaring on both sides. With that I got the degree as 2. Okay, in the next presentation I will consider a few more differential equations, and I will explain uh, how to find the order and degree. Thank you for watching this presentation. See you in the next presentation.